Hello everyone! So today I wanted to do something different and have a little bit of fun, and I hope you can learn something from my experience and from this exercise. But without further ado, let me introduce the idea. And the idea is actually to try and rewrite my old application. If you remember, I had the Pizza backend, or if you haven't, I actually posted a couple of courses on Udemy, how you can deploy and build the applications using Azure DevOps or GitHub Actions. And in this case, I used the Java backend application to show some pizzas and pick some random pizzas. And I always wanted to try and play around with different programming language. And one of them that I really wanted to try, it was Go. I played around with Go just a little bit before, but it wasn't really real experience, and I still have no idea how to use it properly. So a huge disclaimer right now: the code you will see right now or in this video, it is not a production ready code, and we probably should have a discussion about production ready code a little bit later, just in general. But for now, it is only for experimenting and poking around, and I just wanted to show you how I did things and what I wanted to do. So, first thing first, to discuss what we have in my Java application, because it makes it really easy to get things rolling and to have something done for the other application when we want to translate. It's basically like you have really good requirements already available, and my requirement right now is to make a copy of this Java application, but rewrite it in Go and have the same functionality. So what we have in this application, the very last thing that should be taken care of is that it is Dockerized. So the application is executed as a Docker image, and that is very helpful for us because basically if you could run this application as a as a Docker image somewhere, so for example on your local machine, that would mean that it should be executed the same way anywhere else, and we could just play around only locally. There is no need to actually build that image and push it to the Docker Hub and then try to deploy it to web server somewhere to have it actually running, but you can prove that everything works fine just locally. Then the next thing that we have is that it is a Spring Boot application. And for that Spring Boot application, we have a home controller, which have a couple of endpoints. The very first one is just a home page, which will display some sort of a message. And then we have this one is the second one, the interesting one, to have a random pizza read from the database. So if we will go to the repository, it's actually a JPA repository over here. So we are reading all of the pizzas and picking up the random pizza to display. And we show the ingredients and the name of the pizza as a response. And the next thing that we could notice over here is that we actually have a Spring Boot Actuator implemented, and we have some details, so we can display some version, but it's not so interesting. We have some health indicators, and I think the most important bit from the health check over here is that it pings the database if it is available or not. So we definitely want to have something like that to be able to verify that the application, when it started, that it actually works as expected and can deliver some results and not only rely on random pizza to be displayed for the user. And that's pretty much it in terms of what we want to achieve. And I think it's good enough to have it. So the first thing that comes to mind and a question, how to start with this one. And I actually already have everything of those things implemented in Go, and hopefully there will be not too much of the editing and annoying GIFs in this video. But I'm sorry in advance if there would be any issues with this one. So to start with the Go language, what I did first is I just Googled straight away how to create a simple web REST web application with Go. And somehow this was the top article that was suggested to me. So I quickly scrolled back over here and pretty much copy pasted all that thing. As you can see, if you know Go, it is pretty simple and pretty basic, and it's just the beginning of the article. And somewhere here, it's even just saying that you need to get it a little bit more serious. But I pretty much ignored all of that, and we could just copy all of that stuff and see how it will go. Then that's what I implemented. So we copied that whole thing, and to start it, it was initially in my main Go file, but I then moved it to a separate file just to have the web server handled altogether over here. And you can see that it actually very similar to what you have. So we have a handle function for the root, where we will just display the same thing, hello, and escape the URL path, like here. Then I implemented the health check that will be served over here as well, but we'll come back to that a little bit later. And then the pizza to get the random pizza as we have it in a Spring Boot application. And that's pretty much it. We serve the code as port 8081, and that's it. Uh, then I did a little bit of tweaking and wrapped everything in a function. So all of the web handles are served from this function, and it is executed from the main file, main function of the main package that I have. Uh, so all of that was nice and easy. And obviously, as a prerequisite, you had to install Go on your local machine, and you can run it. What I wanted to achieve next is to see if I can, as I said, have some sort of actuator for Go. I actually did some Googling, and there are available packages for the Actuator Go, but those that I find, they were on a GitHub, and I didn't really like that they have some sort of a random name of a person who forked it from somewhere or just developed. So for this purpose, I decided that, well, we actually don't need to have a full-fledged actuator with all of the metrics and traces and so on. And basically, what I want to do is just to be able to verify if the web server is up itself. So we should be able to hit something and receive the response. And the second thing is if the database connectivity is there, yes or no. And actually, I don't want to rely on a random pizza to get that, but instead to have some sort of a ping of the database available. And that's actually a great segue in terms of database access, because that is the next step. So I Googled a little bit more in terms of how to get to the database and found this article. Now it's from the Go documentation itself. So I trust this a little bit more. And over here, you can find, if you scroll down, 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 you can just find how to connect to the database. And basically here we configure something, and there is this ping function to test if the connectivity to the database is available or not. Great, so let's do that. And before I did that, I read a little bit more and realized that actually we aren't. Yeah, interesting. I forgot to delete the comments about the albums by artist, but I will show that in a second. But basically, what I realized is that with Go, it's better not to just have a separate Go files, but instead to have a module declared. So that's what I did next and declared a module. That was once again from the Go documentation over here, and there is a separate part of it, how to write Go code and what is the best way to do it. So it was uh, something like that in the create Go module. So I did that thing and created a Go module, but I named it, as you can see, it's a Go. And basically added some dependencies based on what I found that is required. And those dependencies were for to access the database, and that would be a Microsoft SQL database. I have that database running as a container locally, and it is the same one that was used for my Java application. So it's really nice to have that kind of verification that if something is working for Java code and I can get the results, those same results should be available for the Go implementation of the code. So for the database, the ping function itself, it's very easy, and I just copied the connection string details based on the documentation once again. So I googled about the access relationship, relational database. I'm sorry for my language. Sometimes can be a little bit tricky. And basically, what I needed is to access not MySQL as it is over here, but instead to access the where is it? I haven't prepared it, but how to access the Microsoft SQL database. And in order to use it, I'm using the SQL Server driver. So everything is nice over here. I have a shared connection string for all of that, and it is for now hard-coded, but at the same time it can be easily read from the environment variable instead of just hard-coding it like that. But locally everything works fine. And for the ping, it is exact copy of this code snippet uh, from the tutorial from the Go documentation. Great, everything works fine so far. So you can see that when you know what to get, it's very easy to copy paste random bits and pieces from the internet, smash them together, and hope that they will work. So the next thing that I wanted to have, as I said, is to have a random pizza. So once again, quite easy to Google everything and get that example. And as I showed you by this comment by artist, albums by artist, it's actually a copy paste but updated code from that same tutorial. So if we search by artist, that would be the function that I borrowed from this documentation and changed how it looks like and what we want to get. And we return some pizzas. The next thing that we would need to do, because it is returning all of the pizzas and it's a replacement for the JPA repository code, we actually need to get the random one. And once again, Google for the rescue. That was the answer from the Stack Overflow that I used. So it's very easy to do. And yeah, copy this and use it as an example. Over here, we pick a random pizza. I have put something on top of that from the console because initially, when I tried to encode this, it as a JSON as an example, it didn't really work, and the issue was because I declared the structure for my class for the pizza is that I put everything in a lowercase and obviously, for those who know Go, it would be really clear that it didn't really work because when you have something in lowercase, it is not exported by default, and only if you have things in uppercase, you will get that publicly available. And in order to serialize or deserialize something, this encoder, for example, for the JSON encoder, you need it to be exported and available. So it was a little bit interesting to find what's going on, but a little bit of Googling and fixing, and we have this server up and running. The last thing that I actually need to implement, and that came a little bit later, it would be from the main, and you probably saw it over here, to have a migration. And that part actually gave me the most pain, trying to understand how to run it and whatnot. But basically, what I want to do is to have migrations available to be able to control what pizzas are there and not. And that once again already was implemented over here. For the Java code, I actually used the liquid-based migrations. For Go, liquid-based is not available, and a little bit of Googling suggested me to use the Go migrate or migrate over here like that. And this kind of documentation, unfortunately, I didn't really like it because it wasn't really clear. So you can find this snippet, and I started to base my work from this. So as usual, I Googled first, copied that whole section, went to a separate file, created a function to run the migration, and tried to use this uh, with some additional configuration because I want to read my migrations from the local file and I want to connect to the SQL server instead of the Postgres server as it is in this example. And initially, it didn't really work. And I was banging my head for, I think, a couple of evenings while preparing this example. And the result was that you have a strict naming uh, process for those files for the migrations. And the first one should be the ID or the number of the migration, then underscore name of the migration, then dot up or down to be able to run up migrations and down migrations, and finally dot SQL. What I missed initially is that you have to have that number two for the ID of the migration in the beginning, because without it, the files would be read, they would be evaluated as something, but they are not updated and not used when we started. So with all of that implemented now, I can run the application like go run, and hopefully it will start. So when it starts, it will just say that it is connected to the database, and we should be able to go and check it localhost 8081, and it just says hello, like in our web server over here. Yeah. And if we test pizza, it should give us some sort of a random pizza as a JSON output. This one is having some troubles with encoding of the ID, but at least we can double check that this pizza is indeed available. So that's my connection to that local database. And over here we can quickly check that we have three pizzas actually, and as I said, that test pizza, it was me trying the script, then the new pizza is inserted from the migration finally, and that was my initial pizza from the database from the Java times. And the migration itself, we can double check because I said explicitly that I want to have pizza data dot migrations. So in the pizza data schema, the migrations table to have all of them, and we have applied migration version 2 based on that name of the file, and everything is good. So far, so good. Now let's test. So it is a new pizza with all of its ingredients, and we can test the health. If I type it correctly, and here we have the status up, so that means that the database connectivity is there. If we would stop the SQL database container, so the connectivity to the database obviously wouldn't be available. It will still work, and that's what I wanted to have. So instead of throwing a fatal exception and break everything, it now will show that it is down, but we could still hit some random endpoints and the web server is working, but obviously, because I have no exception handling implemented, if we hit pizza, it will break the whole thing and no more possibility to connect. But the health check, at least, it was working, and that's, I think, great for me. That's exactly what I wanted. So the last thing that I wanted, and that was the first thing that I mentioned in this video, It's about the running everything as a container. So let me start the SQL database again. And once again, that's my usual approach to try to Google things. You could find a Go Lang based image, which is supposed to be used to building stuff. But if you can build your application, then you can run your application from that same one. And yeah, here is a quick example of how to use it to start the Go instance of the application. And that's what I have. So the same Docker file is over there, pretty much. So we download all of the dependencies if anything is needed and run the application because it will be compiled into the code already. So it's not like we run it using Go, but it will be compiled version of the application. And it is possible to run that. Let me quickly copy paste this instead of trying to type. So we can build my image that will be called test go because I don't really want it to be production ready, and then it would be possible to run the application the same way. And we are going to expose the port 8081. Now it's built, and we can run our container. We should be able to, but it didn't really run. But nevertheless, that's what I wanted to show you, and I will fix this one and more fun. And maybe in the next video, I will touch base of what I consider to be a production ready code. But in this video, I wanted to quickly demonstrate how I usually approach something completely new and try to understand what I want to do, how I want to do it, and if it is possible to do something that I want to achieve or not. And I think it's a very good example and way of doing things when you learn things. And when we are software developers or IT professionals, we have to learn all the time, and that's half of the fun of our job, right? Cool. So I hope you enjoyed this video and see you next time.